Hello everyone, my name is Isaac, and today I'm going to explain my practice about the clock divider implemented on the DA10 light, FPGA using Quartus Prime Light and VHDL. In this project, we designed it and simulated and implemented a simple circuit that divides the 15 MHz internal clock of the FPGA to produce a much slower clock signal. This lower signal can be used, for example, to blink a LED or control slower digital processes. So let's start with the FPGA. With the VHDL file. The entity is called clock divided, and it has three main parts. CLK 15 MHz. This is the input clock signal from the FPGA, which runs at 50 MHz. RS reset clock. This is the reset input used to restart the counter. And clock out. This is the output clock after division. Inside the architecture, we created a 26-bit signal called clock temp, which works as a binary counter. Every time there's a rising edge of the input clock, the counter increases by 1, taking one specific bit from this counter. In this case, bit 23, to get a much lower signal output. For example, using 23, the output frequency becomes around 2.98 Hz, which means one cycle takes about 335 milliseconds. This is slow enough to be seen as a blinking LED on the board. So let's go to the test bench. So in the test bench file, we simulated the clock behavior. The simulation generates the input signal clock 15 MHz switching between 0 and 1. Switching between 0 and 1 every 10 nanoseconds, creating a 20 nanoseconds period that's the 15 MHz clock. The output clock out was observed in the waveform and show slower square waves, confirming that the frequency was divided correctly. So you can see it when you go to run simulation and RTL simulation. So let's go to the pin planner. So here you can see a clock 15 MHz was assigned to the P11. Clock out to the A8 and reset clock to C10. So after that, we go to the programmer and upload the project to the FPGA. So see you in the FPGA. So here you can see the LED blinking. So this is the reset switch. So when we turn on, it stops. And that's it. See you in the next FPGA video.